Okay, good morning and welcome to our channel partner community across EMEA. My name is Derek Rattensee. So today is our first session around AI in healthcare. And as you will know, we will have a series of these presentations between now to the end of January, that's 2022. I'm also joined by James Norman, Craig Rhodes, and Arshad, who would be our key presenters today. So the session today, again, is split across two halves. Your first session is focused around prepared presentations, and this is again led by James, Craig, as well as Arshad. James is the CIO for healthcare at Dell Technologies, and Arshad, who works along with James, is the CTO. Craig joins us from the NVIDIA side of the business. Now, the second half of today's session is question and answers, really, and your opportunity is to talk or even ask questions of the presenters about the healthcare side of the business. Now, just on that note, and while I pause, I'm going to ask James' first question around healthcare and healthcare transformation. And what do you think, James, is driving healthcare today and AI within healthcare?
Thank you, everyone, for joining today. What I wanted to do is just give you a quick overview about why AI is important. So my name's James Norman. I am the Chief Information Officer for Healthcare across health and life science for the EMEA region, part of the global healthcare team within Dell Technologies. My background has been health throughout my whole career and supporting organizations around change. Now, I've spent close on 30 years now working in health, and one of the key things there is I've seen a lot of change. Quite specifically, one of the changes that I have experienced has been this move from the paper-based record that we had 10 years ago, where everything was moved from hand to hand, from department to department, quite often big delays. Data would get lost, records would go missing, pages would fall out, and there was this disjoint between the handover of care. It also meant that you would have days, if not weeks, between a sample being taken for a test or a diagnosis coming back to the patient to identify what the problem was. This meant that systems weren't very well connected, a lot of frustration for clinical staff, and for the patient, it really meant pretty poor outcomes at times, where diagnosis that could have been treated quicker, or clues to what was happening with the patient were missed because of manual overview and no data to support a diagnosis. And to be perfectly honest, almost a guess being made by clinicians as to what was actually wrong with the patient. And it also meant that it became a real challenge as we've moved forward to streamline the performance of our teams, to improve the amount of patients we're able to see, and to change the whole nature of how we provide care. So we've continued this sickness model where when a patient gets sick, they come and see a doctor. So by the time they're seeing the doctor, they're already ill. They're already developing symptoms. They're already progressing the symptoms. And really, the doctor is in a race against time to try and understand what's happened, what treatments need to be made, and which pathway of care that the patient really needs to be pushed on. And it becomes really hard to try and coordinate that care across multiple teams. Now, with this big push to connected care across care providers, out in the communities, out in the hospitals, across different hospitals, such as the heart pathway or the pulmonary care pathway, it's really difficult because you're having to move data, be it digital and paper, from one team to the next without any loss of communication with care, or you're having to take notes again from the patient. You're having to ask the patient each time about key questions to confirm that actually what you've been handed is for that patient. So it becomes really confusing and really hard. But what we're actually moving towards is this wellness-focused world. And over the last 14 months since the pandemic started, we've seen this culture change where essentially, people have recognized that we can't just continue to treat people when they arrive at the emergency department, but we've got to be more proactive because, we are identifying new ways of engaging with patients, new ways to treat patients, new technologies to support decisions around what pathways of care the patient needs to go on. And really, we need to look at, how can we reduce this burden that's hitting us? We know that, 50% of the global burden of disease is to do with chronic illness. These are assessments that have been made time and time again to look at things like heart disease, cancer, diabetes, obesity. These are not disappearing. In fact, if anything, they're actually getting worse. And these comorbidities and these chronic illnesses have been identified as, some of the biggest impacts on healthcare. And over the next, 20 years, the World Economic Forum has identified that the impact could be over $47 trillion just from cancer, diabetes, mental illness, heart disease, and respiratory diseases. Now, we can't carry on trying to tackle these diseases in the old way of working, where we have a handoff of care from one department to the other. We have to keep going back to the patient, asking the same questions. We need to make a paradigm shift in how we move from this reactive care to being proactive. And that means we have to bring in new technologies such as artificial intelligence, machine learning, deep learning, to support decision making by clinicians and actually identify what we can try and prevent. 98,000 deaths have been identified as being preventable, just in America alone per annum. Now that is astonishing when you think about that. 98,000 people died that could have gone on to live full, and rich lives purely because their disease was not identified or their pathway of care wasn't properly identified right up front. And as time went on, it became impossible to actually then turn it back and give them the right care. So really what we need to focus on are what we call the 4 Ps: predictive medicine, preventative medicine, personalized medicine, and more importantly, participative medicine. This is about getting patients to form this social contract of care and actually get involved in their treatment pathway and take ownership for taking their medication at the right time, for entering data or wearing the wearable devices to capture real-time data that can then be fed back to the clinician so that they can understand about whether the treatment is working. And this is really about creating this patient-first data-centric world where we're moving so fast. We need to understand, we can't look at the data in real time as humans. We just can't do it. We need to use artificial intelligence systems to track the data in real time and use intelligent alerting to let the clinician know what's happening and also to let the patients know what's happening. And by doing so, we can really move the dial from this sickness model to a wellness model where we can take advantage of virtual care systems that actually are responsive to the patient's needs and are built around the patient. Creating that patient-first data-centric world is critical if we are going to change the mindset of how care is provided and how we are going to reduce this burden, this cost of treatment for even those 5 chronic illnesses. And that's taking aside long COVID and the impact of the pandemic and what's going to happen, because we just don't know what that impact is yet. But we know that the only way we're going to be able to cater for it is if we change the dynamics of how health is being provided, where we're providing virtual visits, we're reducing face-to-face requirements, we're bringing in new technologies to automate systems, improve security, use facial recognition, wayfinding when a patient does have to come in, make it easier for the patient to actually access services, look at new disease management capabilities, bring in genome sequencing, bring in AI, ML to automatically track and monitor patients' early warning signs. And really what we're talking about is building this wellness model where it's not just about one or two systems. We are taking everything into the account. So for the GP and the physician, they have a direct interaction with the patient. The patient is no longer feeling isolated, but actually is put in touch with other patients with similar conditions. The GP is using AI systems, digital twin systems, synthetic data systems to model care pathways and to understand for Julie in this example, what is going to be the right treatment pathway for Julie? How are we going to make sure that the care pathway is tailored for her, but we're bringing in the learning from other people who have got similar symptoms with a similar phenotype to Julie to understand which treatments, which drugs, which follow-ups are required, how frequently, and what the onus on Julie is going to be. So really what we're doing is we're creating this wellness-focused patient data-centric world. We've moved away from that sickness, and now we're able to expand the care that we provide into systems that are designed around the patient, be that at the home, at the hospital, from the way that they access services, even to the way that we carry out treatments. We are able to bring this new technology into bear to provide better care. Use the data that we are capturing in real time from IoT devices, wearable devices, monitoring devices, intelligent cameras that are looking at the patient and checking the movements, even things like gait management as a patient walks into a hospital, just to get that greater depth of intelligence about the patient's symptoms, about how they're managing those symptoms, rather than waiting for the patient to try and remember what's happened to them in the last 3 months since they last saw the clinician. Or, and especially something we see with elderly patients where they don't want to be a burden. So they try to make light of the pain and the symptoms. And so they hide some of the things that are actually happening to them. This way, we're removing that by putting in this intelligent monitoring, using AI systems to manage the care and actually to monitor the patient and what's happened over the period since the clinician last came in. The clinician comes into the consultation fully armed with all the decisions, lined out and options made available to them to then discuss openly with the patient. And it becomes this more joined up care. It will improve outcomes and it will tailor the care for the patient whilst reducing the cost and the burden on hospital providers. So that's where I see care moving to and why data and AI is so important as part of that journey. We all have a part to play as part of providing this care. And it's really important that we understand that technology is an enabler. It's going to support care being provided differently, but it's going to enable clinicians and patients to create this social partnership where they can take ownership of the care, not have to worry about providing information or tracking it or remembering it because it's being done intelligently. And the clinician doesn't need to try and guess as to what's happened. He has a repository and a data bank to support him. Thank you. I'll pass over to Craig and Derek, back to you.
Absolutely. Thanks, James. Great presentation. So we now move on to our next prepared presentation today. And this is going to be delivered by Craig. And Craig again leads the AI practice for healthcare at NVIDIA. So Craig, do you want to talk to us, please, about AI and how is this again impacting the healthcare side of the business, including any use cases that you may want to highlight from an NVIDIA and an AI perspective?
Yes, I'd love to, Derek. Firstly, obviously, thank you very much for Dell for inviting me here today. It's all about partnerships. whether it's what James has talked about, the patient and the clinical partnerships, or whether it's partnerships to deliver the technology. That's key, and especially as we're moving into this new kind of world. Although we've seen these kind of waves before, so partnerships for us is key. And not to repeat what James has expressed, but we've seen many challenges over the years, and like James, I've been in the healthcare system a long time, seen many kind of waves of new technologies, changes to the healthcare system. And it's interesting, James talks about personalized medicine. I think probably in the 30 years James has been in healthcare and the 20 years I've been in healthcare, we've been talking about personalized medicine or healthcare, and we've still not delivered it. And these challenges are, the challenges behind that, the amount of increased inpatient demands, and again, won't touch too much on COVID today, but, the influx of patients, they've completely shut down the healthcare system that we across the world really because of the pandemic. And we've had the effect of having to deliver new drugs and new vaccines in unprecedented time. We are used to drugs taking 12 to 15 years. Majority of the time they're failing 85% of the time. This is just unheard of in any other industry. And yet we are requiring them now to deliver new vaccines, within a year, within 2 years. So again, changes to the environment that we're working in, the deluge of data, the complex data sets that we're working under. We've got 2D, 3D imaging data. James again talks about genomics data, petabytes of data coming daily out of healthcare systems. And then on top of that, we have the regulation of technology, moving away from the old kind of, or the kind of still world we live in around the medical devices, but now into this new world of AI, where algorithms are being developed and created very, very rapidly, but still fall into a somewhat of an old and stilted process to get them into clinical care and start looking at how they are creating new improvements into that care process, that clinical care. So lots of challenges out there today, and I think we can all agree. So briefly as well, and then I'm sure you all know who NVIDIA is. Our background, obviously in graphics and HPC, your children will obviously know us from the gaming industry, but we've also been in healthcare quite a lot, at least for over 10 to 15 years. Started really in the radiology side, nice transition from the work that we were doing in graphics to applying that into a vertical industry like healthcare, being able to look at an image and start to identify artifacts within that image. And then we started to see, it's not a brand new wave of AI. We've seen AI before, but it's certainly a new wave of AI with the technology that can also cope with the demands of the data as well. So this is this kind of bringing together of data and technology and intelligence. And this is where, where we see genomics, where we see pathology, where we see lots and lots of different types of data, 3D data, 3D molecular data, microscopy data, all coming at us and all being identified in very, very new, interesting and challenging ways, and trying to pick out new insight from that data. And previously, the technology was really a big limiting factor in this. Now we see technology as a real enabler to gain new insights. And again, this is where a partnership with Dell and NVIDIA is really, really key. So, and just a couple of areas where we're seeing some real innovation. And this is innovation in data, innovation in the medical devices, the instrumentation, but also in the way that these instruments are being used as well. So we see here some of the big traditional players, Siemens, GE, Varian, United Imaging. These organizations have been producing, imaging data a long, long time. They've been doing it very, very well. But now they're looking at how can they produce more information out of the imaging data. How can they identify artifacts? How can they embed algorithms within the devices? How can they have edge AI that's very close to the imaging, the CT scanner, the MRI scanner, so that you're not just getting a very nice high quality image, but you're also getting some metadata from that image as well, and that might give indications of or areas of interest. And so this is a really kind of new, interesting area that we're seeing from the big providers, this acceleration into artificial intelligence, but bringing, the more traditional world and this new world certainly together. The other area is miniaturization, and this is really, really kind of interesting. One example here is Oxford Nanopore. You can see it's a lot kind of flip top, looks like a flip top phone, the old kind of Motorola phones. And this is a sequencer. So this sequencer can sequence your human genome. And this is remarkable. If you think maybe 5 years ago, you would have to be paying, a couple of $1 million for a big Illumina sequencer. You would have to have a very, sterilized environment, a lab to put the sequencer in. You can now take this into a field in the middle of Africa, sequence cassava plants, understand if that cassava plant has been infected by whitefly, and then determine what you're going to do with that plant. And this is actually a project that NVIDIA has been involved in with Oxford Nanopore as well. These are being used, these small sequences are being used at a local level for COVID analysis as well, looking at variant detection of the types of COVID. So again, this miniaturization and portability of technology that's applying artificial intelligence is creating this kind of new paradigm of being able to take the information, get the data at the actual source. So it's really, really interesting how this is actually working. The next slide, and again, next area, James kind of touched on this. This is computational genomics. So for a long time, and there are volumes of books that try and describe the human genome. And it's amazing when you look at how many volumes of books there are, and then you look at how much data there is. There's 3 billion base pairs, so 3 billion letters in a certain sequence to define a reference genome, and we're all different. So it's a very, very complex, challenging area. And again, the limitations of compute has really challenged us being able to progress really genomics. Genomics has always been seen to be one of the key breakthroughs for personalized medicine. But even in some of the really large national sequencing programs, it's been delayed by the infrastructure, getting the data, getting the analysis of that data, and getting the data into the hands of the clinical teams to really start to make sense out of this. We are now working in a world where, again, we're seeing organizations like Oxford Nanopore embed algorithms into their sequencers and really start to use artificial intelligence. We've now got the whole genome sequence down to 32 minutes. This is unprecedented. 5 years ago, in my previous organization, this was an 8 to 10 hour process using a lot of cores to process this data. We can now do it in 32 minutes. So that's changing and shifting the way that we think of using genomics in care. Now, genomics in research, very, very common, and we do a lot of that. But genomics at the point of care, still a very challenging area. And this is a really key kind of milestone for NVIDIA. This is probably one of the starting blocks for NVIDIA in healthcare in Europe. And this is where we have really taken what we would like to do in healthcare and really try to expand out with a partnership. And this partnership is with King's College London. And King's College London they're kind of one of the founders of taking artificial intelligence for healthcare and really trying to apply that across a large healthcare system, not just looking at a single disease area like stroke or Alzheimer's, but taking that across many different clinical pathways such as neurology, oncology, and cardiology. So very, very high value areas of care. So, and this is also across 11 NHS trusts. So 26 million citizens. So it's an enormous population set that we've seen, and enormous kind of demographics. If we look at artificial intelligence and some of the challenges that people talk about around areas like bias, we want the diversity in the demographics, the diversity of the population set to really help us inform that data. So this area here, this is the Sanger Institute, and I think this was the first time at NVIDIA that we realized we were onto something quite serious in the genomic space. It's a partnership with Dell, and this is where we've been working with the Sanger Institute for a long time. But we unlocked something here, which was how to really transform science by using technology, but also by understanding the science behind the technology as well. The Sanger, one of their largest cancer programs is called Mutagraphs. This is looking at mutations within your DNA based on historical lifestyle events. So things like alcoholism, smoking, sensation, these kind of big events that certainly change the way that you are as a human inside, the physical you. This process was really trying to kind of aim to look at how the DNA changes, how it changes within yourself based on these events, so that can unlock how do we then apply certain treatment protocols to this. So it's really important, and again, going back to the personalized medicine world. Now, when they were running their application ran in 30 days. So it's quite a long run, taking a lot of cores, CPU cores. So you've got your inputs, you're putting your data in, and then you're going away, putting it 30 days later, you get your outputs. So this is quite a challenging process for such a kind of a life-changing program and one of their leading cancer programs to, effectively have to wait 30 days to get the data back. When NVIDIA and Dell got hold of this, we started to really look at how the application was developed and how we could parallelize the work that was being done. And we got this down to 30 days, down to 6 to 8 hours. Now, why is this so important? This is so important because it fundamentally showed NVIDIA that there is a lot of work to be done in these historical applications, and to you as partners, there is an awful lot of opportunities out there to accelerate these kind of more kind of older applications that can be brought into the future. And by taking this down to 8 hours, they could do a run every 12 hours. So every 12 hours, they can do an input and get the output. So when you're doing a big, a world-challenging scientific project, the iterations you're suddenly having are 365 iterations versus 12. So again, it's just amazing. 4 months worth of effort between the partners, and then a complete change in the whole of Sanger's program. So amazing work that was being done. There's a great white paper on this as well. So just shows that the scientific value out of these can be supported by the technology value that we can provide. And one of the areas of artificial intelligence that is mostly challenging for a lot of people is the security, the understandable, the explainability, the governance, the ethics, these kind of very loud statements that we hear from a lot of organizations, and certainly organizations that are challenged in how we explain what we're doing, how it's been done, and how we get to the results. One of the kind of changing processes in this world is federated learning. And again, it's a really good read to look at this kind of new area that's come into the healthcare industry. And this is the idea of keep the knowledge, keep the data where the organization is, where the hospital is. And in this case, we've got a number of NHS trusts. We'll have 11 NHS trusts working under the Federated Learning program. But in the pharma space, there's about 10 pharmaceutical companies across Europe doing this federated learning. And this helps with the ethics and the governance of the data. Still, you have to still go through the ethics and governance approval, but that challenge around security and moving data to, a large data lake, which is not the wrong answer. This is just another way to do it. So where there is a massive impact on security, ethics, and governance, federated learning in this space is a really, really kind of new, interesting area. This is one that's been adopted by many, many organizations, especially in the clinical space. So again, something very worthwhile for you to look at. And I'll quickly skip through the last few. Why is NVIDIA so good in this space and the work that NVIDIA and Dell are doing? Well, actually, when you put it on NVIDIA Dell technology, the acceleration that you can get into standardized processes, whether it's in genomics, as we talked about, medical imaging, 30x. It's not 30%, this is 30x. These are enormous accelerations. This is doing things in weeks and months or doing things in hours. And we know that people are desperate in the healthcare industry, again, as James has pointed out, to get the data, get it quickly, identify what we need to do, and then put the patient on the right clinical pathway to get the best possible outcomes. And then when we look in the pharmaceutical industry with structure, screening, docking, simulation, these big areas that the pharmaceutical industry are really interested in drug development and design, again, there's huge acceleration to be done. And just at the end there, natural language processing, this is one of the biggest areas we're seeing coming up at the moment, this NLP. And this is where we're starting to look at structured, unstructured data from clinical systems and start to be able to use that in artificial intelligence, such as looking at predicting certain events in personal lifestyle based on some of their clinical data. So where we can start to track patients and then have early warning signs, maybe based on some of their wearable data of certain events. So very, very interesting that NLP now is coming into play. And this in the world of healthcare, that structured data from the Epic systems, the Cerner systems is enormous. It's enormous amounts of data. There are a plethora of kind of software stacks out there. Again, one of the things that NVIDIA has invested an awful lot of time in is this development of software on top of our hardware around, and Dell wrapping around their hardware and infrastructure around to that. We focused on a number of key areas in genomics, natural language processing, imaging, edge computing, which is obviously a big area now, and in some discovery, which is in our pharmaceutical kind of space. But if we, just as an example, look at the edge technology at the moment, we're doing a lot of work in endoscopy, scoping. We're looking at how we on the fly can recognize areas of interest as that person is being scoped. It's running the algorithm very locally with a very small edge device with the endoscopy feeding the device data. And then if it does find a new area of interest, being able to annotate right on the fly and say this is something new. Then being able to take that new data and go back to the server, rebuild the algorithm, so the next time the system understands that this is an area that we now recognize. So that whole process, that workflow is now connected by edge data center. So it's a great new kind of area that NVIDIA and Dell are kind of forging in. And the kind of area around endoscopy and scoping, surgical, the kind of digital surgery of the future is really, really exciting. We've said a lot so far. Where's the evidence? From NVIDIA's perspective, our evidence is going to be in Cambridge 1. So Cambridge 1 will be the largest supercomputer in the UK. Our founding partners are AstraZeneca, GSK, the NHS, Oxford Nanopore, King's College London, and the priority around this is for healthcare research. We know these organizations have got enormous data sets. We know they've got enormous challenges. We do not want to limit them by the technology within these organizations. So we want to show them what supercomputing technology can do for drug discovery, for clinical care, for genomic sequencing, and for research. So it's a huge investment from NVIDIA, but with Dell and NVIDIA and our partners and our customers, we want to bring them to Cambridge 1 to really show them how supercomputing facilities can really change people's lives and make a real difference. So again, going right back to the beginning, we're seeing the technology as the enabler, the disruptor, not the blocker. And this is a real kind of change in the way that we're now thinking. So thank you very much.
Now, we do have one final presentation coming up before we move into question and answers. And we do have a few prepared questions as well as questions from the audience. But before we do that, let's welcome Arshad. Arshad, I know you're going to look at AI use cases and where are some of these use cases impacting customers today? Do you want to give us a view really on some of the use cases that you're seeing?
Thanks, James and Craig. So guys, my name is Arshad Fahad. I'm Chief Technology Officer for Healthcare and Life Sciences in Europe, Middle East, and Africa. Likewise, James and Craig, I've been in the healthcare industry, working in the healthcare for the last 12 years or so. I'm based out in the UK and work in the National Health Services for 12 years at different various senior leadership roles. Over the next 15, 20 minutes, I'm going to go through some of the key challenges and some of the areas where we have helped as jointly NVIDIA and Dell, bringing our customer into the AI journey and path. These are some of the areas where we've seen not only in the UK, but obviously more in the wider geography of European and some Middle Eastern countries as well. So very quickly, let's look at different AI journey index, right? So not all customers are equal, right? And in the same fashion, different region and different countries, they are in the different maturity model of the healthcare digital transformation. And more precisely, in the AI journey, they are in a different level. Some of them are still thinking whether it is the right thing to do, and it may be a number of reasons. Maybe they're concerned about security, they may be concerned about governance, and some other ethical reasons could be as well. But at the same time, we have seen and we are watching, we are observing a number of organizations who have gone in much advanced areas, especially in Middle East countries. Like they have been doing genomic sequencing, Craig has talked about, and James has mentioned sequencing, precision medicine, and they have been doing for quite some time. And the discussion over there is more about how they could speed up the process rather than when we're having this discussion in some other countries, like how we can adopt it. So it's a different conversation in different countries and different customers. But if you have to generalize it, and I think that is something I hope you would agree as well, that most of or majority of our customers are more in the explorer phase at the moment. Like they have had some set or some partial deployment of AI, and the word AI is quite broad, right? And again, the adoption and the meaningful of AI can be treated as different at different places and with different people. Like very basic, it could be some sort of data warehousing people have been doing, or healthcare organization have been doing. They have a separate data warehouse department, which are there to take meaningful information out of the data, whether clinical and non-clinical. Example of such could be patient turnaround time, payments, those sort of things. So some sort of AI is there, but they are seeing a lot of, in the last 12 months or so, since we have come across this pandemic, we have seen the adoption has increased significantly. We have used the use case of AI in medical imaging, whilst a number of organizations or healthcare providers are using AI to detect COVID patients or COVID symptoms, those sort of things. So what we are seeing here is, I think, is well to understand your customers and the market, right? So not all the customers are the same. So you may have different conversation at different areas and different customers. What are the challenges and what are the reasons behind those different AI journey model? And I think this is probably, you are all aware of that. I'm not going to go through each and every of them, but I think one or two probably I would focus on here and spend a few minutes is, I think, data architecture challenges, data and architecture challenges. I think this is one of the areas, obviously being Dell and NVIDIA board technology company. So we see there's a huge gap in this area. Some healthcare organization, or not only healthcare, some life sciences organization, they may also think that the existing infrastructure, which is based on, or which was deployed 5 years ago, it may be well enough to cope the requirement of AI, machine learning, and deep learning. And again, this is something probably we as a technology partner like yourself, like Dell and NVIDIA, we may have to, we may have a good role to play here because, the architecture for implementing these areas like AI, machine learning are significantly different than the normal traditional architecture. Align process aligning, and this is one of the areas like in a healthcare provider, and this is from my personal experience when I used to work in the healthcare industry in the NHS in the UK. Like the technology element of a solution is very small. It takes 3, 4, maybe 6 months, but the processes behind the clinical processes that takes a huge amount of time. So it like 2 years, 3 years. Like giving you a simple example, just James talked about digitizing a paper record. Right? Again, from the technology perspective, it sounds very big about a technology perspective, maybe 3, 4, 6 months. But the process behind the clinical process to move away from paper process to a non-paper process is huge, it's significant and complex as well, because there are huge dependencies. Similarly, when we talk about the AI and adoption of AI in the clinical space, the process moving away from the current process to a newer process obviously takes time. And this is where the organization are facing some challenges, huge challenges, in fact, that how they could move away from the existing challenges, because these processes are not just within their hospitals or within their care providers. They are interlinked to other places or other people, other organizations as well. So these are some of the areas what we're seeing as healthcare organization are facing challenges. Ethics, Craig briefly mentioned about ethics challenge that is still a place, and I think in some countries and region, I would say they have done well. They have formed an ethics body for the AI, how they could use the AI in the healthcare. So I think slowly, but we are getting there. I think there is a huge need of those ethics body in other regions where they don't have it at the moment, and also the integration of technologies. Again, like the presence of siloed information or data that we have at the moment in healthcare. I think that's also obstructing the adoption of AI. I think this is the area where technology providers such as yourself, partners organization, Dell and NVIDIA, we have a huge role. So how we get there, how we help our customer getting on to the AI journey. So for us, I think there's no secret. Craig previously mentioned the adoption of federated learning. I think with the past, obviously it is still new, but I think we have seen the data the more and more data is being generated through the edge or through the edge devices. So it may not be as centrally. So there's a huge demand for having some processing or AI or some algorithm to be run at the edge. So the new world obviously is comprised of edge, core, and cloud. There's no deny to it. And I think it's similar in other verticals as well, not only in healthcare. So I think the pragmatic approach, which we normally suggest and what we've seen successful in other areas or in other elsewhere in region in the EMEA as well, is first of all, get the customer to think about what use cases they would like to address. And these use cases doesn't need to start from a very complex one. It could be a very simple one, right? In the next couple of slides, I will talk about some of the basics use cases, what we have done, what we have helped customer developing and using them. So yeah, think about some of the use cases which they can do. And that may also depend on the data they have, because anything what we are doing or what we have talked so far, whether it's AI, machine learning, deep learning, natural language processing, they're all depending on the data. So data quality, obviously, the first obstacle they need to come over. And again, going back to the same stress point that as a partner organization like yourself, Dell and NVIDIA, we have a huge expertise in that area to help our healthcare providers and the customer there as well. Next, in that approach of adopting AI is obviously getting your infrastructure right. And this is where probably I'll come to the next slide, because look, when we talk about structure, unstructured, semi-structured, Fourier unstructured data, again, going back to the same first slide or second slide I think mentioned about, like infrastructure is still being seen as a challenge, how people have the right infrastructure to adopt AI, whether on-prem, whether in the hybrid cloud setting. So when we look at the structured data, this is where, like, I'm going back 10, 12 years ago, like every majority of healthcare providers have some sort of business intelligence department. some SQL, Oracle, those sort of databases. And they're crunching data to get some meaningful information out of whether attendance, whether leaves, those sort of things. So obviously, this is where you're talking about like terabytes or maybe megabytes of data and tens of maybe multiple of 10 of CPU. So there's not huge amount of compute and storage requirement over there. But as we move from structured to semi-structured or fully unstructured data, then the requirement to process those data becomes significantly huge. So for example, if you move into deep learning area, so again, deep learning, to learn a deep learning on a medical imaging or a video surveillance, I would say it's very challenging just to use CPUs. So this is where obviously the adoption of GPUs and associated technology really helps. And obviously when we move into the data territory of petabytes, then you require significant and probably slightly a different type of storage as well, right? Maybe the block storage may not work well over there, maybe object store or file store, depending on the use cases, right? So this is something we will have to, and this is something we ask our customers to think about before they get into the AI journey. Think about the infrastructure, because although it's not going to take huge amount of time to make shift into that, but at the same time, it is very critical that you have the infrastructure right to make sure it supports your future plans and processes. Very quickly, some of very general use cases where we are seeing, again, these are some of the use cases I've put together, considering we have audience here from healthcare and life sciences area both. So if you classify like the first two, improving clinical care at home, this is where we talk about more of the edge software. We use the edge AI or machine learning algorithm to improve bringing some detecting of early disease, like especially in the beginning, James mentioned about obviously the chronic disease, and because of the challenges that bring chronic diseases. So rather than bringing those patients into the hospital, obviously these days the focus is to keep those patients out of the hospital and treat as much as when they're home. So on those areas, obviously early detection of disease is one of the main focus for healthcare organization and providers. So again, AI are playing a huge role and part into that area as well. Population health, I think that's not new. I think this is, you can take an example of recent COVID or pandemic that I think majority of the countries and regions, they have some sort of population health solution running to identify which area are affected most. Like if you're in the UK, you can think about, they have classify the whole region country into yellow, red, or amber areas. Obviously, that depends on how the data has been coming out from different regions. Either some outbreaks are prevailing over those areas, those sort of things. And when we go into life sciences area, so this is more of the precision medicine. Again, it's been discussed previously by my previous two colleagues, and the drug discovery. This is where the life sciences area, and they have been using for quite some time. And the adoption we've seen in the last, like, if I put into perspective the recent COVID, if you look at the last pandemic, which was Spanish flu, 1980, 1990, the deaths were nearly 60 to 100 millions. Fortunately, this time the casualties are less than that. And I think it's been recognized by World Health Organization that AI, specifically AI and technology, has played a huge role, whether it's a healthcare setup, whether it's a life sciences or pharmaceutical setup, by creating drugs, by helping the life sciences organization to create vaccine. It has sped up the process quite significantly. So like the purpose of these use cases, like when you speak to the customer, like these are just to give you some idea. There are hundreds of other use cases, right? Some of the use cases, like going back to my life in the healthcare, actually working in the hospital, we talked about predict readmission risk for nearly 12 years ago. Probably James would remember that. Like these use cases has been there for quite some time, and they have been adopted by a number of organizations. Again, the word may not be AI that time. They may be data science, or they may call it just a business intelligence process, but it's there. So again, it's better to start with the established use cases and then move into more complex and the recent. Right. Looking at the time, so very conscious. So in the next couple of slides, I'll probably going to go through very quickly some of the use cases we have worked recently in the last 12 to 18 months, and well, Dell and NVIDIA have joined together and help organizations in the AI journey. So in the medical imaging is obviously is an area where we have seen a huge adoption recently. A number of organizations across EMEA, they have used chest X-ray as a way to help radiologists to detect COVID, right? As one of the examples. But what we see in the clinical value, obviously, is not just that. Obviously, they are different people, as I said at the beginning. They're different journey or they're different index at the moment. So some of them may only be using for detection purposes. Some of them may be using for actually measuring it, like the extent of it, or some of them obviously in some areas and some regions where they are more advanced, or some organizations who are more advanced, they are also using it for predicting as well. So it all depends on where you are, which region you are, and what is the maturity model in terms of AI. One thing to be very clear here, I think these are the questions where we get asked quite often regarding ethics and governance perspective. Look, AI here, especially in the healthcare setup, is here to help clinicians do their job better. It's not there to replace them. So that's a question I think probably you get asked. Like get asked this question 100 times every time. Like, are we talking about replacing clinicians or doctors or physicians? Like, well, I can say for now, no, this is not the intent. This is their technology is there to help make their decision more informed, more accurate. At the end of the day, still the final decision is made by the clinicians. A very quick overview of the algorithm which is currently being used is one of the simple algorithm, I would say, being used for in the medical imaging. And this could be various. This could be applied on digital pathology. This could be applied on chest X-ray, those sort of things, right? So obviously you have a training part of AI algorithm where you have the training, and just to focus on the right-hand corner where we say is 1 to 3 million patches from 18 classes. So basically these are the classes when you see a single pathology slide. So the huge amount, like the explosion of data is huge. And this is where I said previously that you've got to have the right infrastructure in place, otherwise the solution, otherwise the AI project or journey will fall. So this is something to be very clear and mindful of. Other than that, it is very clear, obviously, it does a training, it creates a training index. And once, if you look at the bottom part of the slide, when you have a glass slide, it's get a scan. WSI is whole slide scan with the whole slide image, basically, and is reviewed by the pathologist first. He makes a decision or he review it first. And at the same time, it goes into the inferencing engine. And it looks into all the previous training data that has been collected over the time. And if it finds the matches, it informs the pathologist. Again, it's not making a decision. The key point is it informed the pathologist, look, Mr. Pathologist, I've seen this pattern in 10 years ago, patient XYZ, and that time that pathologist diagnosed, that was the treatment, that was the diagnosis that time. So it helps pathologists making a more informed decision. So maybe if I'm a pathologist or radiologist, if I'm reviewing a slide, I have made 30 or 40 year experience, right? This is what the current process is. But using the AI, you're utilizing hundreds of pathologists' experience and millions of slides or decisions which has been done in the past. So you can see the quality of the decision, how the AI is helping the clinical setup and deployment. Okay, I've talked through it, so I'm not going to spend much time on that. So a couple of the use cases we have seen. Pneumonia is something that's been used quite widely and quite some time. The recent COVID-19 using chest X-ray, number of organizations in the UK, in the Middle East, in the Germany, France. I think every region have used some sort of AI. I won't say everyone, but some organizations have used chest X-ray as a means to detect COVID patients. And obviously there's some AI algorithm which has been developed by a number of partners. I think there are quite a few partners who have worked in this area, which again, give alarming to the radiologist, like it could be a detection of that. Machine intelligence or machine learning, tumor detection, this is the same example. We have worked with, in fact, I'll move into the other slide. We have worked with Sectra, and we have also worked with another digital pathology provider called Huron Medical to create an end-to-end solution. And it's based on very simple: scan, index, and detect, right? So a scan, basically you scan the whole glass slide, which is the first using some digital scanner. And the next step is obviously look at the viewing and indexing it. Indexing part, basically, again, it varies from vendor to vendor or algorithm to algorithms. But for example, taking the example of Huron Medical. So what they do, basically, they take portion of the slide image or the whole slide, whole WSI, whole slide image, and they index in the forms of barcode because every area is different. The barcode single pathology slide, and those barcodes may be in the number of thousands, maybe multiple of thousands. So every area is different and it corresponds to a certain barcode. So that's the indexing part, and then it gets stored into some sort of relational database. Next time when some other patient comes in, they scan the same, and what they do, basically, they now search, they do the same process, indexing, right? They create a barcode, and they match those barcode from the new images to the database they already have. And if they find a match, they just inform the pathologist or the radiologist, yes, Mr. Radiologist, we have seen this pattern in the past, and this is what it was diagnosed this time. So it may be that. But again, decision, again, down to the person who is making, who's a clinical decision, who's making either radiology or pathology. So that's very simple algorithm, but that's an example of how machine learning can help. Machine learning is incorporated into medical imaging arena. Again, we have seen a use case where very relevant to the era we are in, the COVID area, the pandemic. So instead of using wet chemistry, like your PCI test or your clinical test, photography using AI process being used to detect patients, to detect COVID. And it's not only just detect whether the patient has a COVID, also detects whether this patient has antibodies in the past as well, using some AI algorithm. So there's a partner globally, it's called IABRA, and we work with NVIDIA to create an end-to-end solution. This is what it looks like. Passive data capture and dissemination, I think this is one of the examples which has been used in healthcare providers to some form and shape, like they use to see how the hospital is performing, and this mainly based on the data they already have. These data may be captured through some of their EPR, EMR, or EHR solutions. So they see what's the current wait times are, financially how the hospital are performing. So this is more of like crunching the data, not prediction. So as I mentioned before, a couple of slides before, that it could be used to detect it, predict it, or to make all two of it or three of it. So this is like very basic format. And I think in the past, it used to be done in data warehousing or business intelligence department. But again, with the passage of time, the adoption of AI, there are more advances to those processes have been made. And this is a very well-known use cases. And I think I would say this is mostly adopted area where hospitals and healthcare providers have used AI in their regions. Very, very recent and very timely solution, I would say, thermal solution. Obviously, this is not just to detect the temperature, this is a resistance step, but also like in airport, in hospitals, where you have your entrance foyer or your reception desk, to make sure that patient or people are still observing social distancing, they're wearing masks. So AI has been used on those application, those use cases as well. So again, we have worked with a company called IntelliSight and conjunction with NVIDIA. There are a number of solutions. The one you're looking at is on a trolley. So basically it's a trolley, you have a camera, you have a workstation which has GPU cards on it and some direct attached storage, and it does real time. At the same time, it can be done centrally as well. So for example, in the such as airports and such as other big shopping mall, the same use case, but what they do, they also detect if the people are observing social distancing, they're wearing masks, those sort of things. So AI obviously has been played a vital role in those areas as well. So here you go, guys. These are some of the examples, areas which are currently we are seeing at the moment. But as we said, I think we all three have said, like what we have seen in the last 18 months is our adoption has significantly increased. people and healthcare organizations have realized the value of AI, and what they've been seeing is, yes, is a key driver for getting into the digital transformation journey. And so with that, I will hand it back to Derek for the second part of the session. So thank you very much.
Thank you, Arshad. Lots of interesting information. You've heard three perspectives from James, from Arshad, as well as Craig. So what we will do now is move into the second half of the session. I'm just conscious of time, and we've got about 20 minutes to take questions from partners. Well, I do have a few questions here as well. So my question, or my first question really to the panel would be, is how are NVIDIA and Dell placed today, and how do we support partners across the region? And I'm not limiting this to UK, France, Germany, but some of the other partners, right, in Middle East, Africa, as well as the CEE countries. How are we placed today, and how do we support them through this process, helping them understand the healthcare market to start with, and AI within the healthcare market? I'm not too sure what order we would like to follow, but we could have a response from either James, Arshad, or even Craig for that matter.
Shall I start? So at the moment, we are very closely collaborating on a number of initiatives across Europe. If you approach either myself or Craig or Arshad, any of them, or your partner account manager, they'll bring us in. And although we will be having separate engagements in terms of interaction, we will work hand in glove with each other to make sure that the interaction is seamless from a Dell and an NVIDIA perspective. We've got great SKUs already set up, reference architectures. We train each other on the technologies so we understand which servers and which chipsets work well, the capabilities of each other. So with that respect, Derek, the NVIDIA relationship is very strong, and it's not a we'll bring them in and leave it to it's we do work very closely together.
I think go on, Arshad.
Yeah, I would just add to what James has said. Like, I think the good thing is, I think there is no conflict of what we do and what NVIDIA does. Right? So where we have worked in the past, and we have seen some very significant successes now across the whole region, not only UK, France, and Germany, as I said before. And so yes, if you think about inviting NVIDIA into some of the discussion regarding the AI, maybe NVIDIA further invite Dell Technologies to talk about more of the other areas where the AI solution may fit in. So yeah, it's been long-standing relationship between NVIDIA and Dell, and it has been going, and it's been increasing significantly well in the future as well.
Yeah, I think it's very complementary, and it's something that I've not really struggled with, and I think, kind of building on what James and Arshad both said, I think if you look at NVIDIA and where NVIDIA's invested, our resources and our engineering team, we are really an engineering organization. 80% of our organization are engineering. There's very few people like me, to be frank. But we focus on some very, very specific challenges. Dell give you that real holistic view, and you can tell that by listening to James and what James talks about the healthcare system. He's talking about the whole 360 healthcare system. Whereas, slightly in my presentation, I drive into very specific user cases and requirements. And I think that's the collaboration, is that when you bring Dell and NVIDIA to get together, we can bring very, very deep-rooted computational chemist experts into it, very specific genomics experts into it. But we don't understand the whole big picture, and that's where Dell come in with their experience, or we come in to Dell, and we bring that kind of holistic experience that also can drive down deep into understanding what those customer pain points are. To me, it's always about that. When you bring us in, you'll find people at NVIDIA and Dell that will understand the customer pain point, whether those are deep-rooted engineers in a computational challenge, or whether that's a healthcare system looking for a complete transformation.
Absolutely.
Thank you, Craig. So I do see that there's a question here and questions from the audience. It's from Vibin Vijay. And his question really is to yourself, Craig, and it says, you mentioned about 16x improvement by use case from genomics, imaging, NLP, and so on. How do you rate their ability or readiness in the UK?
Yeah, really good question. So it's getting better. So there is a lot of education to be done. There are a lot of resources to be put in place. And there are a lot of collaborations that need to come together. But we've seen movements, and there's a really good example of this. And again, something Dell are very much involved in as well is Genomics England. Genomics England have been for a long time kind of working on a very specific technology pipeline that fitted a particular type of compute platform. That compute platform is not advancing. It's kind of there because it does a particular type of genomic workload very well, and there's no disagreement with that. But that workload, that computational platform just doesn't move forward. It's not moving into artificial intelligence because it doesn't need to. NVIDIA's focused their GPUs on genomics and AI. So it's a much broader set of kind of skills. Genomics England have started to pick this up, and then that's accelerated very, very rapidly. Genomics England suddenly realizing GPUs can mean much more than just accelerating a single pipeline, but actually bringing artificial intelligence to all of their researchers and all of the clinical teams that are now seeing AI as part of genomics and not the kind of traditional pipeline. Now, the point of that is to say it's taken about 3 years. Since I first joined NVIDIA 4 years ago, I started talking to Genomics England. I've known Genomics England for 8 to 10 years. But it's taken 4 years for them to get that. It's taken a lot of conversations, a lot of education sessions, a lot of sitting down with them and talking to them about it, and to move them. And we are seeing that in the clinical domain as well. But there's got to be a clinical driver. This is not a technology push to get IT people with the latest shiny boxes. There's got to be a clinical challenge, a clinical transformation to drive this through. And if you haven't got clinical teams driving the challenge, it's not going to go very far. So, we've got to have a look at that kind of holistic, multidisciplinary team that brings the data scientists together, the clinicians together, the technologists together to really work on that challenge. So I appreciate that you may not feel that the IT organizations aren't coming to you and saying, I've got a clinical problem that I want to start talking to you about AI. But I bet nearly every single one of the 217 trusts, there's somebody in that trust at a clinical level working out how can we deploy AI in our organization.
Excellent. Thanks, James. Again, channel partners, teams, please do ask questions through chat. Happy to, again, direct them to our panel. I do have a few other questions. Now, we talked about reference architectures briefly, including reference to ISVs. Now, conscious that reference architectures are the building blocks to the larger solutions we create for our customers. Could you then talk to us about the reference architectures between NVIDIA and Dell, and how are we differentiated in the market, please?
I'll start that one, and possibly other can join as well. So, in terms of reference architecture, right? So, the two areas Dell and NVIDIA have done a great job regarding AI and other use cases regarding machine learning and deep learning. So what we have done is, with joint engineering and with joint collaboration, we have created not only reference architecture, but we have also created some ready solutions for AI. And what it provides to our customers and partners is basically make AI simpler to embark onto that journey. Obviously, if you start on the AI journey, initially you don't know what you are embarking on, right? So these ready bundles, they really help. And when we say ready bundles, they have compute, memory, storage, and GPU. They're all built into a specific numbers, right? And obviously they are scalable. Either you can scale out and scale up as well. So these are ready windows obviously able to use for the general purpose AI use cases. The other area which you specifically about, Derek, was the reference architecture. So reference architecture comes in play where we work with a specific partner to validate their solution to make sure their solution work seamlessly in the Dell Technology and NVIDIA platform together, right? Example of that, I think I mentioned one of my presentation, we work with digital pathology who have AI, machine learning algorithm runs on the digital pathology image. So NVIDIA and Dell, we both work with the Huron Medical, who will provide us the solution to create a reference architecture end-to-end right from this scanner, which is a part of their proposition, the Huron Medical proposition. They provide the scanner. And after that, going into the workstation, going into the storage, going into the processing cycle where you use memory, GPU, and everything. And further down to that, when it goes into the archiving for long-term retention. So right from the acquisition of the image, processing, and eventually to the retention, we have created an end-to-end reference architecture. And this is just one example. There are other 10s and 20s and 50s other examples where we have worked collaboratively, NVIDIA and Dell, and created a reference architecture for that partner. And the idea is very simple, right? And is very seamlessly, right? Is that obviously, as I mentioned about the collaboration between Dell and NVIDIA, and also it gives peace of mind to the customer that the platform they are investing in or they are buying in is going to work and is going to work as per the specification of the software or AI vendor. I don't know, James or Craig, would you like to add something to it?
I think I think you're right, Arshad. I think a couple of examples that I would kind of highlight, Astrazeneca. So I think Dell and NVIDIA have really kind of turnkey the work that we do with Astrazeneca. You know, this is highly complex work, very, very challenging workloads, very large workloads, but a constant need to make sure that they've got the latest acceleration, because they're obviously in a hunt for the vaccine and making sure that the vaccine is doing the right thing to the new variants that are coming out. So they're always needing to have the latest benchmarks, the latest technical teams coming together. So I think the reference architecture is always great, but the reference architecture is always as of the day that it's produced. We are moving, accelerating very, very quickly. So there's nothing like also bringing the team in to talk to your customers about what their latest technology advances are. But again, as Arshad said, pathology, genomics, the kind of medical imaging, and NLP, those are the big user cases that are driving AI, and those are the areas. And the edge side of things, again, are packaged out. And those are the kind of areas that Dell and NVIDIA package up just so well. And deliver a kind of complete solution in there. And then there's a whole kind of value add that we add on top of that, whether that's experience, expertise, resources, open source software. We all know about open source software. Predominantly our route at NVIDIA around our imaging platform is open source it. We want to get it into the community's hands. So there's a lot of technologies out there. It can feel challenging and can feel like it changes a lot. So there's nothing like just bringing us both into the conversation and talking to us about it.
Excellent. Thanks, Craig. I know you sort of briefly touched on challenges there, but one of the challenges that we tend to hear more often within the healthcare industry, also with AI, is the ethical issues and the biases that AI may bring. There is a fear that potentially AI could replace doctors. Are you all able to talk about AI from an ethical point of view, please?
So we've been doing a lot of work at the point of care and delivering solutions. And if we look at the King's College example, one of the biggest challenges with King's College is the breadth of the deployment of the AI platform that they're trying to do. This cuts across 26 million people, 11 NHS trusts, and a huge demographic population. So what's really crucial here is, A, it's great to have a diverse demographic population. You know, look at West London, Westminster, Chelsea, Kensington. You know, the demographics there is very, very different to East London. And I think it was Lord Darcy used to talk about the train line that goes from West London to East London and the kind of decline in the survival rate for cancer patients because of the depravity in East London versus West. So there has to be this melting pot of data that covers many demographics. So that's an enormous consideration. You know, if we only had one particular type of of demographics, we would only be, you know, able to use that particular algorithm on a certain population set. And we just know no country or country region is made up like that. The other big area is to have the clinical teams on board. These are the people that understand the ethical issues, whether you're writing something down on a piece of paper, you're entering something into a clinical system, or you're developing an algorithm. Ethics is always at their forefront of their mind and consideration. They have to be part of the process. And the other part of this process is the patient, and James talked about this brilliantly. But the patient, you know, the patient and the patient advocates and the family and the carers. You know, it's great to go and talk to them about these things and talk to them about what could AI mean to them. There's a lot of patient advocates coming now onto the board of the big clinical AI programs. And then again, that's crucial for them not to feel like, the robots are taking over their care. There's a lot of comments previously by one particular person about radiologists being removed from the process. That's absolute nonsense. But the AI systems should be supporting. So our language and the way that we talk and the way that we perceive AI should not be as a replacement, but as an enhancement. And the clinical teams have to be engaged right at the front to determine the ethics of what is being done from a technical perspective, but also what the implications clinically are to the patients as well.
Team, thank you for your time today. Thank you for listening to us. We look forward to seeing you on the next Champions Call, which is on the 21st of July, where we will discuss AI in the transportation space. So feel free to get in touch with us for further support. But thank you again for your time today.
Thank you, everyone.
Thanks, everyone.
Thanks, guys. Bye-bye.